Myself, Divisa Sindhuja Vankineni, and my friend is Samhita Samidhi, and we have joined together for doing the DCSE final project about voice controlled smart retail store. So, what do you expect when you go to a shop? You would want one of the staff member to come to you and ask, like, what are you looking for? What product you are seeking for today? So, this is exactly what our voice control system will eliminate. It will act as a medium between you and the products so that you can enhance your shopping experience in that particular store by doing some voice command features to search for products, or you can ask that assistant to know about this particular clothing section or footwear section and the navigation to that. Or else you can also contact like customer support and find out about written policies or refund requests, and also like give feedback about the store in particular to the assistant so that the store can improve their performance the next time. When it comes to the software components in our application, we have used the databases of PostgreSQL from the Google Cloud SQL, and we have also went through adding the Google Cloud endpoints for API management and security. We also use Redis for storing the key values, as well as the main part of our project, which is the speech recognition and NLP, which is done by the Google Cloud Speech to Text API, and vice versa, as well as the dialog flow where intents and entities are stored. We also use the IAM to manage the roles and cloud resources, and Google Cloud monitoring and logging for debugging and performance and system health. And finally, we use Docker and Kubernetes engine for DevOps and deployment. Coming to the hardware components, we use the servers, which are the cloud servers from the Google Compute Engine instances. This is the high-level architectural diagram of our product, and basically what happens here is the system components interaction here is that we have the voice processing, which takes the user command and then transmits it to the Google speech to text API so that the text will be extracted from that, and then we give it to the dialog flow for intent recognition, and which the intents will be forwarded to the backend processing, and they will then filter out the database to find out the relevant products or the relevant response, which will be again displayed to the user at the front end to and also convert the text response to the speech output on the website. So the potential bottlenecks are, first one is speech to text processing, where voice recognition could become a bit jitty sometimes if there are multiple speech inputs. The second one is database queries, where complex product queries might become problematic, and for the Google Cloud SQL to when querying the Google Cloud SQL, so that next one is the scalability during high traffic, which ensures scalability. So very high traffic might require additional optimization. So this is the cookie website that we have, which acts as a smart retail assistant. And in this website, first I will start with a greeting to the assistant. So I'll click on the speak button so that it will take my input. Hello.
Hello. How can I help you?
So then I'll proceed to ask it details about a particular product that I want to find. For example, like this. Find me a black shirt in size medium.
Found one product based on your search.
So now it's showing me the product from filtering out in the database, which has the following details, which is black in color, and which is the product category shirt, and which is of the size medium. Now I'll go with asking for navigation regarding a particular section in the store, like this. Where is the clothing section?
Found one section based on your search.
So it returns me the clothing section navigation details, like location. He's specifying the aisle 2, specifying the directions to take from this kiosk. And after this, I can go with asking about the policies of the store, for example, like this. What is your refund policy?
Found one support query matching your question.
Yeah, that's how it returns the refund policy, and it tells me details of when will the amount will be done to my bank account once the refund is done. So after this, the last one is I can try out with giving feedback about this particular thing or about the store to this assistant. So I will start with this example. I want to give feedback.
Please provide your feedback.
I love the shopping experience.
Thank you for your feedback. We value your opinion.
Yeah, so once it asks me for providing the feedback, I give the input to the assistant and it stores this feedback input in the backend database. Now we can test the other use case, which is about finding the discounts that the store currently has. So we can go with an example like this. What promotions do you have currently?
Found one active promotions.
Yeah, so with this, it finds the active promotion which is like last until 14 December, and it gives us the details of that promotion along with the promo code.
Let me now walk you through the Kubernetes manifest files and how we have deployed on the Kubernetes engine. This is our cluster. We have created with minimal requirements, minimal memory, minimal storage and all, because we didn't have much of load as of now. So this is our cluster. These are our pods and case and alias for kubectl. You can set it up in the bash rc file. Instead of typing kubectl always, you can just do get pods. And then these two are our application pods. This is our application. And you can also describe the pod if there are any errors or memory requirements, you can get the events of that pod and why it has why it is going into crash loop back off state or any such kind of event. And then this is our deployment file, manifest file. So we have added 2 replicas. So you can see that we have 2 replicas. And then we have also deployed Redis with the help of Helm package installer, and can exit into the pod, go inside the pod, do Redis-CLI. You can go inside the CLI to know what how the caching works, if it's actually working and all. This was very helpful when we were testing out if Redis was connected and all. Like you can get the keys by key star like this, and you can get the logs by doing kubectl logs in this pod. And we also have a secret attached to this. So we have attached a service account to our Dialogflow API, and then that JSON key we have enabled it as a secret over here. This was much more safer than having actual path or putting it somewhere else, because credentials should not be shared publicly. And we also have PostgreSQL as our database. This is the instance. This is the database. And so we set up this database like first we have created a service account, and we assigned a Cloud SQL role so that it could be granted access for the SQL instance. And then with the help of workload identity, we linked the service account to the Kubernetes service account, like through the IAM role binding and all, so that our application pods could be authenticated without actually storing the credentials and all. That's how we set up our database. And we also have unit tests to check our application. And to show the role binding, to verify, this is the command, like to check if it's binded or not. And then we can see the service account it has been binded to, and we can check it in the IAM roles if it's existing over there. We also have service.yaml, ingress.yaml as well. So with the help of the ingress, we have hosted it on HTTP. So you can get Django service.
Flow that we have. So in this one, what I have did is we have added this following intents so that the Dialogflow NLP can work and recognize the intents like the welcome intent, and the most important find product intent, where it will be categorizing stuff based on this things like color, product, and size, and then it will segregate those, filter those stuff, and give us the parameters to the backend of our database in the views.py. And then we have similar other things like navigating the store, discovering the discounts, and yeah, the feedback also, where it will select that this is the feedback intent, and it tells the Django application that the feedback is being asked by the customer, and it has to generate the next follow-up question of providing the feedback. And after this is intents, we have also added entities into the Dialogflow, so that these are the following entities under which it categorizes the parameters. And yeah, using this, we have connected this one to the Dialogflow query function in the views.py, and where it filters out the stuff and gives us the parameters to the database, so that we can filter out from the database and finally display the relevant products or other information in the front-end application.